This is the last section in chapter 5. The big idea for today is called the hinge theorem. And there are a whole bunch of words that you can read there. Picture a hinge opening and closing though. If you make your hinge, make a small angle. So let's say my hinge is really, really tiny like that. The side across from my angle in the triangle is going to be small. If I take my hinge and I open it up to make a big angle, the side across from that angle is going to be big. So that is what the hinge theorem says. If two sides of a triangle are congruent to two sides of another triangle, and the included angle of one triangle is bigger, then the third side of that triangle will be bigger. Or if the included angle of one triangle is smaller, then the side across from that angle is going to be smaller. And then the converse is a theorem but backwards. So if you have two triangles with two congruent sides, and the third side in one is bigger, so I didn't draw my picture very well. Let's say I'm going to open this one up. So in this case, the triangle on the bottom has a bigger third side. Then the angle across from that bigger third side is going to be a bigger angle. And this is kind of a whole bunch of words for something that is pretty much common sense to us at this point. All right, let's apply it. So we want to compare WX and XY in this picture. WX is across from a 51-degree angle. XY is across from a 55-degree angle. So according to the hinge theorem, the segment that is across from the bigger angle is going to be the bigger segment. So WX would be less than XY. All right, in B, we are looking at the measure of angle FCB. So that would be that one. And the measure of angle BFC. Oh no, FCD. That makes more sense. Sorry about that. So we're comparing FCD, this angle, and BFC, this one. Well, if you look at these two triangles, we've got one set of congruent sides, BF and CD are congruent. We've got a secret set in the middle. CF is congruent to itself. And then you look at this included angle. Well, our first one, BFC, is across from a 3.6 unit side. And the other one, FCD, is across from a 3 unit side. So the one that is across from 3.6 is going to be bigger. So that was BFC. The measure of angle FCD is less than the measure of angle BFC. All right, last example, I want to compare the measure of angle R to the measure of angle T. Well, R and T are included angles between two sets of congruent sides. R is across from a 20 unit side, and T is across from a 21 unit side. So T is going to be slightly bigger. The measure of angle R is less than the measure of angle T. So again, the hinge theorem is a whole bunch of words for something that we kind of already knew based on the triangle inequalities that we learned yesterday.